Now let's look at installing Snort as an NIDS. It's already compiled with MySQL support, so we need to create the database schema. Now luckily for us, the schema comes with each release of Snort. So let's label this section Snort NIDS Setup. And there are many steps that are required. Step 1 is to set up MySQL DB environment. If you're using a different DB engine, then you can follow along with these steps, but import the schema file for your DB as opposed to the one for MySQL. So step 1 is to create the environment. And there are a series of commands that we need to execute on the MySQL server. First is to create the database Snort. So we'll execute a create DB Snort on the server. Let's connect to our MySQL instance. Or MySQL, since we have it running locally as opposed to on a remote system, we'll do it here. MySQL prompt for password user root. And then we'll execute the create database Snort. Now that the database has been created, we need to set some privileges. And we'll execute a grant insert select on root star to Snort at localhost for the new user Snort that we'll be using in the configuration in order for the NIDS to connect to the DB. Then we'll set the password for the user Snort to a simple ABC123 by using set password for the user Snort at localhost. If you recall from our MySQL section, we mentioned that MySQL users are based on the username as well as the host name. So there's a function password that will pass in ABC123 into, and this will set the password for the user Snort at localhost to be ABC123. So whenever the user authenticates, the user will match, hopefully, the ABC123 which has been set. We need to grant the appropriate privileges on the Snort DB to the user Snort as well as Snort at localhost. Let's grant create, insert, select, pretty much all the rights, delete, update on snort.star to the user Snort at localhost. And we'll repeat this step for just the user Snort, not Snort at localhost, but Snort on any host. And let's do that once more, but this time just for the user Snort, which means it applies to all users named, or the user Snort at any host. So step E resembles the following. Now our permissions are in place. Everything is set from a permissions perspective, although the DB doesn't have any tables. If we use Snort, show tables, nothing exists. So at this point we need to import the schema. So let's exit. And step 2 is to import MySQL DB schema. To do so, we'll execute the MySQL client, authenticate as root, be prompted for the password with input redirection, one of the few times we've used it throughout our studies, the path to the create MySQL script, the schema script, which is located beneath home Linux CBT temp Snort, followed by Snort and the version 2.8.0.2. Schemas create _MySQL, and we'd like to have this script apply to the Snort database. So if the path is correct, this should execute from the shell. So MySQL will connect to the server once we provide the appropriate credentials and import the contents of the create _MySQL schema script. And we'll echo the exit status, and all appears to have gone well. We can confirm as such by reconnecting to the server using MySQL uroot prompt for password. And once there, we'll use Snort and then rerun show tables, which is in our history, and there you see the initial schema that is supported by Snort. So this is in place as expected, so let's quit MySQL. The tables have been created, all looks well. So we've imported the database schema, we're ready to move on with Snort in NIDS mode. It's ready to log. Now, the next step is to set up Snort NIDS etc Snort environment. To do this, we'll get the files from the etc directory located beneath the Snort version directory. So let's SU in because we need to be root to make these directories. Navigate into temp Snort, into the version directory, and beneath that version directory is an etc directory which contains files which we need to create in etc Snort. A generic snort.conf which we'll need to update to support the database, as well as other important files, classifications, references, signature maps, and so on. The signatures in Snort are known as SIDs or SIDs. These are the IDs maintained by the Snort team. So let's copy the contents. We'll copy star into etc Snort. Now, etc Snort doesn't exist, so we'll make it first, then follow that using logical ending with copy everything from here into etc Snort. And now it exists. But we're not done. We've copied what we need to, and we'll just include the command make directory etc Snort followed by copy v home Linux CBT Snort version etc star to etc Snort. The config files are in place, but we have no rules. The primary config file, note Snort's primary configuration file is etc Snort snort.conf. This file references, and this is for NIDS mode, that is. So Snort's primary configuration file for NIDS mode is the following. This file makes all references to the plugins, the preprocessors, the rules, the different networks that are local versus remote. All of those references are maintained in this configuration file, including where to log Snort's findings, in particular alerts that match the signature database. But we have no signature database, so step 4 is to download the latest Snort rules file and extract to etc Snort rules. And to do so, we'll need to connect to snort.org, log in. So let's navigate to the website. We'll need to log in and download the rules. Now, just a quick note, Snort rules are available for free. So note, Snort rules are available as follows. Registered users, which has a delay. This means you need to authenticate to the site, to snort.org. Subscriber, no delay. So as soon as the signatures become available, subscribers receive those signatures in a timely fashion. And unregistered users, release version, which is very old, of rules. So ideally, you want to register, at least be a registered user, because you'll have access to the recent signatures, even if you're off by a week or two. But preferably, especially for a corporate setting or for an environment where NIDS monitoring is important, you will want to be a subscriber. However, to be a subscriber, you have to be willing to pay. So this is the not free option, but it's well worth it. The second best option is to be a registered user. There's also another way to download Snort rules, and that is from various third-party sites, such as Bleeding Snort. etc. Just Google Snort rules, Snort signatures, and you'll see various sites offering them. Now we're going to go the route of a registered user. We have an account with snort.org, and we'll download the most recent rules. Now when you navigate to Snort's website, navigate to rules, and all of what we just mentioned is explained on the page, whether you're a subscriber, registered, unregistered. If you're a subscriber, you get real-time updates. If you're registered, you get rules that are 30 days after the release to subscribed users, and if you're unregistered, you get very old rules that are released with major Snort releases. So you need to make that determination. Now since I'm already logged in, my browser has memory of who I am, I'll navigate to download rules, and for you, simply register with snort.org. You'll be able to download the latest rules, and then scroll down to the most recently released rules, which happen to be very close to our current date. The file will be named Snort Rules Snapshot Current, and the version tar.gz. Here's its MD5 sum, and we can pull it based on this information. So let's go ahead and pull it. Notice below we see rules for the subscriber versus the regular registered user, which is what we currently are. So 225 is for the subscriber. Here are the rules for the registered user, which is about a month old. This is what we have access to. So I'll click on the download of this, and it's session-based, so if you use wget, it may not work. Chances are it will not work. And now the rules will be pulled, perhaps dumped to the desktop in the background, and then we'll copy it into the Snort tree. Let's navigate to Linux CBT's home, temp, and Snort. And then we'll just paste it in this directory using Control-V, then close out the windows. So now we've got our rule set, and it needs to be extracted beneath etc snort into the rules directory. So if we take a look at the current file using tar, let's navigate a level up, using tar tzvf, which will display the contents of the rules file, we'll see the structure that will be extracted when we expand it. It will create a hierarchy with or named doc, which is designated for holding documentation related to the various signatures included with the current rules file, for which there are thousands of rules. And it will also create the individual rules files. So let's navigate to etc snort and then tar xzvf, our home directory, Linux CBT's home directory, temp, snort rules. This will create the tree, the two trees, that is rules and doc, beneath etc snort. And in our documentation we'll just note that. So that's some information about the rules, and we'll just indicate that we've changed directories into etc snort, followed by a tar xzvf snort rules star, which extracts the rule set into two top-level directories, doc and rules. So now if we look at the directory structure, we see doc etc rules as well as so_rules. ls, or ls that is, of etc reveals files that are included with the version of snort, such as the message map, the reference config, and other items. These are just duplicates. But the rules files exist beneath rules. These are the key rules. These are the categories of rules, like how Nessus has various categories of rules for different operating systems and device types. We now can configure etc snort, snort.conf. So the fifth step is to configure etc snort, snort.conf to use MySQL and rules. So A will focus on the MySQL configuration, and then B, the rules configuration. So MySQL is for output configuration, and rules is simply the path to the rules, which will be relative to etc snort, or will indicate an absolute path, which leads to etc snort rules. So let's navigate to the shell. We'll use the nano editor. We'll modify snort.conf, and there are 6 main areas in this file. The last area allows you to customize your rule set. Regarding MySQL, it's in the output plugins section along with other indicators for other DB drivers. But there are some basic settings towards the top and earlier sections, such as what IP addresses define your home net. There's a default setting of any, but if you know the specific IPs, indicate them, such as 10 or 192 or 172, if any of those are indeed your internal network addresses. For us, it's 192.168.75.0/24. If you have multiple internal subnets, as many corporate environments do, such as DMZs, VLANs, and so on, then use brackets to indicate those multiple subnets with the comma separating them, exactly how you see it here. That's our home net. The purpose of the home net variable is to be able to group systems within our environment that belong to us, so that if non-home net IP addresses are detected, they're treated as outsiders. So it's a way of classifying insiders from outsiders. The variable that's set here, external net any, means any other than home net. There are ways to reserve servers for DNS, HTTP, SNMP, etc. And there are many settings in here. An important directive is the rule path. Since we're here, let's just go ahead and set it. The rule path is equal to etc snort rules. This is what we should have in place. Let's just confirm it. etc snort rules. That's the rule path. We want to be sure that this is specified. We can even add some space around it, a comment, official rule path, so that Snort knows where to find the rules we've downloaded. Now, as far as MySQL, we'll Control W to search for MySQL, and here are examples of how to indicate that MySQL should be your database or logging location. Here's also a way to indicate that Snort, when it runs in NIDS mode, as referenced by the snort.conf file, should reference the TCP dump log file, tcpdump.log. So you can turn on multiple logging or multiple output destinations if you'd like. But for our intents and purposes, we want to enable MySQL logging. So we'll just open a space here, paste it, and we'll need to update the credentials to match our server. The user will be Snort. The password is ABC123. And the database name is Snort. The host is localhost, which means or implies that Snort can log to a remote MySQL server. So the Snort box may be one box logged into a remote MySQL server from your NIDSs. So you can have multiple remote NIDSs logging to one or more MySQL servers. So this is how we indicate that the database driver MySQL is supposed to be used. And we're using it for logging. Now that's basically all there is to get MySQL up and running in NIDS mode. This is a basic setup. It can be tweaked, it should be tweaked, but this will get you fired up, get it started, and allow you to start logging packets to the server, to the MySQL server, for later analysis using a tool such as Base, a front-end web-based tool, or some other third-party utility. Now how do we go about starting Snort as an NIDS server? So that will lead us to the next step. Start Snort, or attempt to start Snort as or in NIDS mode. We execute it similar to the way we've done thus far. We indicate an interface, ETH0. It's always a good idea. But we then also include the C option, which indicates the configuration file that Snort's to process. Whenever Snort sees the -C option, followed by, of course, the config file, it knows that it needs to read and operate in NIDS mode. So that file is located in etc snort, and it's called snort.conf. This will allow Snort to start up in NIDS mode. You may optionally turn on the -D option, the upper D option. This demonizes Snort. which means it places it in the background so it can run indefinitely. By that we mean until the system crashes, etc., or until you reboot it. Now let's attempt to fire Snort up in this mode. This will go through the rules file. It initializes all of the rules. It flows through each of the sections that we skipped over in the snort.conf file. And once it's processed all the rules, here we see there are over 7,000 rules processed, it starts. It attempts to connect to the database. If we scroll up, we'll see that it bound to ETH0, and there is compile support for MySQL. Here's the database user. The password is set. The database name is Snort, localhost. The sensor's name. Each sensor or each Snort NIDS box registers itself as a unique sensor name, so that when you use aggregate tools like base, you're able to differentiate one sensor from another. Its ID is 1, its name is the IP address. This can all be configured through snort.conf. The schema version is 107, and it's logging using the log facility as opposed to alert. Here's the information regarding what the pattern matching engine, the Perl-compatible regular expression engine, will use, how much memory, the patterns, so on and so forth. So now it's up and running. But this doesn't mean Snort's going to log everything. In fact, quite the contrary. Now it's going to match and log items that match the signatures, as opposed to sniffing or logging all traffic or traffic based on Berkeley packet filters, as we've shown you in a simple example, a simple way of monitoring TCP port 23 or telnet traffic. So you'll have to trigger one of the signatures in order for Snort to log, such as by executing an nmap, a port scan against the server, for example. But now Snort's logging to that database file. Now, of course, the next step to make sense of this information, or to make sense of what Snort is doing, is to set up base. So set up base web analysis application. This is a front-end tool which simply connects to MySQL, reads the logs created by Snort, and presents it in a graphical format. So that's what it does, and it does so in a really easy to understand way. Now we may download the requisite items for base off the net. One URL to try to wget is the ADODB that's required. So we need to wget, and you can search for this file, by the way, whether at SourceForge or via Google, you can look for it. The URL is easynews.dl.sourceforge.net, and the version that we'll pull is ADODB 480, although there are later versions. This will need to be extracted somewhere that base has access to it, so we'll place it somewhere beneath the web root. Let's open a separate shell, and that's if this downloads properly. We'll SU. If it doesn't, we'll have to go on the net and get it. We'll navigate into our directory. And beneath this linuxcbt.com directory is RH5. We'll just place it beneath www. And it has pulled it successfully. So now let's extract it. So we must set up or extract the contents of ADO. So download, then B, extract ADODB 480.tgz. Just in case you're wondering, note ADODB 480.tgz provides DB connectivity for base to MySQL. This is the means with which MySQL, this driver that is the means with which MySQL will contact, or PHP, the base software via PHP will contact MySQL. It's a driver. Let's extract the contents of it, and it needs to be made accessible. It doesn't need to be beneath the web root. In fact, outside the web root is just fine. So long as the Apache web server has access to it, there should be no problem. This creates a structure, and in it there's a primary configuration file, but the primary configuration file that we're interested in is not with ADODB, but rather with the base software itself. So now that we've extracted ADODB and it's made accessible, the next step is to download base from SecureIDs.net. So we'll be pulling the latest version of base. Base is the analysis engine, the web-based engine, from the SecureIDs.net website. And we see the acronyms: definition, basic analysis, and security engine. The latest is 136. So we'll navigate to downloads and pull 136, which was released in 2007. And again, it's a simple interface. There are other interfaces. This is one of the popular ones, which allow you to process the information, to display the information in the Snort database. And we'll just wait for this to load. It's calling various sites. And we should be able to follow a link. And we see, in fact, there's a later version, 139, which isn't mentioned on their website. So we'll go ahead and download 139, which means the SecureIDs.net website needs to be updated to reflect the latest posted version on SourceForge.net. And we'll just have to wait this out. Again, the process is always time-consuming, but once you're up and running, as we like to say, you then begin the process of learning to use the application. And this here has led us to the wrong site, so we clicked on inadvertently the wrong link, so let's try that again. We could have also clicked on the download link, but we were inadvertently led to the wrong link, which popped up, which explains why it took so long. So you've selected to download the base 139 release, and usually SourceForge will provide a URL in the event that we're unable to download the file automatically. In other words, the pop-up doesn't occur, but this seems like it's going to work as expected, which means the pop-up will come, the file will be saved to the desktop, at which point we'll then copy the file to the web root and extract it so it's accessible to us via the web browser. And again, it's taking a long time. Let's try clicking on it again. It hasn't popped up. Now it's popped up. So let's save it to the desktop. It's a small download. And we'll move it into our home directory. Then from the shell as root, we'll extract base into an accessible location on our server. So let's go ahead and tar xzvf linux cbt, the version of base, which will create the structure here, which is base on the name base dash the version. So this is what we'll access through the browser. Now I like to symlink base or move it to a name such as base or IDS, so it's easy to reference or to use a name that's easy to remember. So we'll move base 139 to simply base or symlink it. But if you symlink it, be sure that your Apache server supports symlinking. Now we need to actually modify the base conf PHP file. That's our next step. And there's a dist file which comes with it. We'll save this as base_conf.php without the dist or distribution suffix. So we've downloaded it. Next step is to configure base_conf PHP file. And there are some variables that are important. The variables include the URL base as well as the DB lib path, where to find the database directory, which we know is ADODB, as well as the database name to connect to, the username, password, so on and so forth. So now we've got this file. Let's navigate towards where the directives are set. There's some items that are already set for us, but the base URL path /base. This is how we'll access base via the URL, via the browser. The dblib path is the next important variable. This indicates where ADODB is located, and as mentioned, let's just find a spare window here, and we did actually free that window. We'll navigate to var www, and that's the wrong directory, so we were in the wrong directory. Let's navigate to serve www, and there's ADODB, so we had in the wrong directory altogether. We need to move it over. But this is the ADODB that we need to reference. Now, a quick check of the Apache configuration will tell us where it's searching for the document root. Let's take a look at conf and grep document root from httpd.conf, and it will search var www.html. So we need to move these items out of var www.html or make changes to the document root. It's easy enough to navigate to serve www and move ADODB as well as base over to var www.html. Now once in var www.html, we'll see that the directories are there, and we'll need to update the base conf. Now, the file that we had open is set to the wrong item, so let's just save the changes to a different directory. That'll be var www. Let's confirm the path. HTML base. And it exists, so we'll simply override it. And then we'll continue to modify the file. In fact, we can copy it now, base_conf to simply base_conf without the suffix, and then proceed with the modification of base_conf.php. So it should have our settings, which includes the URL path, which is /base, and let's proceed with the dblib path, which is the full path, var www.html ADODB. We also need to set the DB type, the database type, which is MySQL. The alert DB name needs to be set. It's not snort_log, but snort. The host is localhost. The port is the default port. The user is snort, but the password is ABC123. And these are the key directives. We're done configuring base. So let's just note we need to set base URL path equal to /base. That's where we will reference the software. We also need to set dblib path equal to the full path, var www.html ADODB. The DB type is already set. The alert_DB name needs to be set to whatever you've created your Snort database to be named, that is. The alert host must be configured, and it should default to localhost, but just make sure it's set, or if you're using a different or remote MySQL server, then set it to what is appropriate for your environment. The alert password must be set, ABC123, and these are the key directives that must be set in the base configuration file. Note, ensure that your Apache instance has PHP support. That's important. And on Apache Red Hat, a quick LSL etc httpd conf.d should reveal a php.conf file, which means it's installed. So we've got PHP support. We've configured base to cross-reference ADODB beneath var www.html ADODB. We should also ensure that the Apache web server has the permissions to write to the ADODB directory, because when we connect from the web browser, it's going to extend the schema. So we want to be sure that it has the rights. PSEF, grep-i, HTTP, or Apache reveals it runs as Apache. So if we chown Apache for base, it will be able to make changes to the files that are in base, which includes the conf file. We should also note that there is yet another dependency. Ensure that PHP MySQL package is installed. Otherwise, base will be unable to communicate with the MySQL server, as it is indeed a PHP process, or a PHP script, a PHP application. So it relies upon both ADODB as well as the PHP MySQL package. With that said, let's connect to base via the web browser. And to do so, we'll launch a browser instance. We'll close this pop-up for a survey, close the Snort website, we've already gotten the software, and then connect to the IP address of the local system, or localhost, depending on what Apache is listening to, /base. This will take us to the setup page, which will commence, or continue the installation, that is. It commences the extension of the database schema. So it tells us the version of the database is valid, but the DB structure needs to be extended to include the following tables. So if we click on Use Setup Page, which takes us to this window, we can create the base table. It's all in red, but it tells you what it's done, and the bottom line is if it returns that it's successful, then you know you're up and running. Now that we're up and running, if we simply navigate to base home, we see the default interface for the software. Now it isn't exciting, nothing much is going on yet because we've yet to see any traffic. However, once we have port scanned the system and it has seen activity, we'll see traffic. It's already seen one packet. Let's take a look. We'll click on it to see what it has picked up. And it sees a 403, or it saw a 403, an invalid attempt. So someone attempted to access a resource that wasn't permitted on the server. You can search for different traffic, filter based on the criteria indicated. And on the left is a breakdown of the packets seen today, last 24 hours, 72, the most recent 15 alerts, and so on. In this area is a breakdown of TCP, UDP, ICMP, and port scan traffic. So now base is up and running, and as traffic is generated against this host, we'll pick it up. If, again, you have port mirroring operating, you'll pick up traffic between other hosts, and so on. One other note, consider protecting /base application using htdigest or basic auth with Apache, so that users are forced to authenticate to the server when accessing the application. Also consider moving ADODB outside of the web root, such as beneath var www or beneath var ADODB. So long as you cross-reference the appropriate absolute path in the base_conf.php file, you should have no trouble whatsoever referencing ADODB. And over time, this will become populated with more information based on traffic. Our classroom environment has no traffic going on, or not much activity, which explains why we see nothing. But nonetheless, it is up and running. It's ready to report on activity. You can drill down by a number of criteria, such as source IP, destination IP. It's quite flexible. You can perform actions based on a specific traffic pattern, such as emailing the alert or deleting it. You can maintain the cache, which contains information regarding recent alerts. There's a comprehensive search feature, which allows you to search based on myriad criteria based on almost anything you can define in a packet, or anything you'll find in a packet, and all sorts of various time values may be used to search for traffic, such as between time ranges. So we've shown you how to use Snort in packet logging as well as packet sniffing modes, as well as NIDS mode. We've told you also that if you demonize Snort using the upper D option, it'll run in that particular fashion. Let's see if Snort's still up and running. And it isn't, so if we launch it again, let's history grep Snort. We ran it with the option that you see here to reference the snort.conf file. And if we run it this way, turn on upper D, this will background Snort after it's fully launched, and it will cause it to run as a backgrounded process. There are also various init scripts available, in particular for Red Hat and for other distros. Search for them, and you can control the way Snort starts and ends. And you can modify those init scripts to work on a per interface basis. So you may have an init script for ETH0, one for 1, one for 2, etc., depending on how your NIDS monitor is configured. Now let's PSEF grep again Snort to see if it's up and running. It is indeed up and running, and will continue to pick up traffic patterns. And before we go, let's nmap or scan the system from one of our remote systems, the SUSE Enterprise 10 box, just to show the traffic patterns from that system. We'll execute an nmap, a service as well as operating system detection scan against our box located at .10. This is a port scan attempt, and now if we return to the browser, let's launch one last instance, we'll see that we've picked up that port scan. This is an SE Linux pop-up we're closing regarding inability to access certain content, which we can follow up on at another point. But now let's connect to the base instance, and on the page we will see if Snort is indeed running traffic related to the port scan, and there it is. So now 43% of our traffic is port scan traffic. You drill down on that port scan traffic and you'll see the various attempts. And you'll see the ports that were consulted, references to Snort documentation regarding the type of scan or attempt against your server, source and destination ports, etc. Pick any one of them, and such as item number of them. Each offense is listed. You'll see the time when it occurred, when it first occurred, when it last occurred, the number of occurrences, the number of sensors that picked it up, you name it. So again, all of the work that you see here is of course provided by Snort. Base is merely a front end, a pretty apt front end which reflects what Snort sees. So the idea is that you need to keep your Snort rules database as up to date as possible, and your base interface will reflect whatever Snort's picking up.